Afternoon. Today, we are going to do combined loading of structure and how to construct an element, labeling of an element. Okay. So now, we are going to have, so I'm going to look at two sets of formula now, okay, which we have learned. Okay. So normal stresses the formula that we are going to use is if I have it as stress X, this will be equal to Px over A plus or minus My over Iyy multiplied by Z plus or minus Mz over Izz multiplied by Y. If we were to look in an element, so if I were to draw a 3D transformation over here, this is X, Y, and this direction is Z. If we were to draw a 3D element, what we have acquired is we have acquired the normal stress in the stress X direction. Okay. And we are aware that this is from what? Axial force. And this are caused by bending moment. Okay. And then if we were to look into our shearing stresses, for this case, I will specifically state that we are looking at shear XY is equal to shear YX. And this will be equal to Tx C over J plus or minus By over Izz Qz over T plus minus Vz over Iyy Qy over T. This is due to torsion. This are due to shear force. So what we have found or would like to find is shear in XY direction, which is equal to shear in YX direction. Now we have to be very, very cautious. The next thing that I want you all to remember now, listen, I think in all of what I've taught, this is not that difficult, but can you see what we are combining, yes or no? We are combining whatever we have learned from the first week to now and whatever you have learned in where? To P04. Are we clear? So we're going to assemble everything to look into a structure that we can determine whether it will fail or not fail. Now, if we were to focus on stress distribution, okay, we are aware that if we have a structure, okay, so this is the cross-sectional view. Okay. If we were to look at a normal stress distribution, okay, if we were to look at a normal stress distribution, okay, this is just a sketch. What you will realize is this. Okay. So for this case, it's under eccentric loading. Okay. Why eccentric loading? Because the neutral axis have been shifted. Over here, this is our normal stress, and this is our y distance. Okay, so what you can see is you have stresses distributing this way. Okay, that is a classical distribution of what? Normal stresses. In your shearing stress, that's why I'm testing you so much on distribution. And this is due to shear force. This is due to shear force. Let's draw shearing stress. Okay, just for I will tell you which is due to shear force and which is due to the torque. And if this is due to, this is our shear force or shear stress, this is our y, we are aware that we will have a distribution looking like this. Okay, we know that we have a distribution like this. And this is due to shear force. So what we realize is we know at this position is our centroid. Okay. So if you look at the cross section, or if you look at this point over here, right? What we realize that the normal stress, right, is approximately equal to 0. For this case, because it's centric, it's not, but it's approximately equal to 0. But the shear stress is what? At its max. And if you pick the other extreme, the normal stress is at its max, the shear force is equal, the shear stress is equal to what? 0. Okay, so you have to visualize the distribution. Are we clear? Okay, because this is important. Because at some points which we will pick, the normal stress is equal to 0, the shear stress will be at its maximum, or sometimes it can be at point alpha. We know that stress, normal stress and shear stress are not equal to what? Not equal to 0. Visualization of the normal stress distribution is critical because we have passed the stage where we state that force divided by area is our stress. Now, all this equation over here, okay, when we see this equation over here, we are able to determine it's what? We can determine its distribution. That is how precise we can get, and that's how precise we will be. We clear? Okay. Now, there's another shearing stress caused by torque, and the distribution look this way. And this is due to the what? Due to the torque. Okay. So at the if you just look at the torque, the shear stress due to the torque is the same as the what? normal stress distribution. Why? Because the formula for the torque is TR over what? J. T and J are constant. The bigger the radius, the higher the what? The value. Okay. Most of the time, students don't have problem with this. Most of the time, students don't have a problem with this. Most of the time, students have problem with this. When I was working with Rolls-Royce, I did not know. I assume it equal to 0, and I just put a factor of safety equal to 2. My first calculation was thrown out the window, and it was an embarrassment. And that was after I finished my freaking PhD. I learned my lesson. Okay, my prof did not care. The shear force, don't bother. That's wrong. Are we clear? Okay, because on an aero engine, safety of factor of 2 means what? The power of ratio, the power to weight ratio, what? Drops. For civil engineers, it does not matter. Mechanical, it does. Are we clear? Okay, now, let's look into a real life problem now. From now on, all problems we do are going to be 3D. Okay. I picked this problem over here. Any idea why? Anyone? Humor me. Why did Eugene pick this problem? I've not seen so many forces acting on a structure in a textbook like this one. Are we clear? It has the most what? How many forces can you see? 4. Okay, go to the textbook and look at and try to find any textbook that has a structure that looks like this. I can guarantee you there'll be none. Okay. So when you just look at it, it looks scary. But once you start doing it, you're going to tell me, Eugene, is that it? And I tell you, yes, that's it. Okay. Right. So let's focus on this question. Okay, this question will take me 3 hours to do. I repeat again, this question will take me 3 hours to do. In your exam, you will definitely get a question like this. It should only take you 45 minutes. Final exam, well, you only will get 3 questions. I have to elaborate, okay? You don't need to elaborate when you're writing, for crying out loud. Okay, let's go. I'm going to write procedures on the way on how we analyze. And you have seen part of this before. Okay, you have seen part of it before. I've planted the mustard seed into your mind, and you have seen this. Hey, I've seen this before. Okay, so you're not going to get any surprises. Are we clear? Okay. 4 force are applied to a W200 times by 41.6 row steel as shown. Determine the principal stress at maximum shearing stress at point A, and we are going to look at point B. We are not going to do principal stresses yet because we have not done mole circle yet. Okay, so in your I know, in your final exam, kitchen sink or throw inside, you have to determine the mole circle and you have to calculate your factor of safety. Okay, so this is just 50% of where we are going. Okay, so and we are going to construct the stresses. Okay, the stresses associated with each element. So at the end of the day, what we are trying to do, can you all see the elements? So first of all, I want you to identify element A and what? Element B. And I did explain to you what are the elements. Look at the wall, right? Now you know what is an element. Yes or no? Okay, like we give you the elements. Okay, so elements you can measure, or the stresses you can calculate. For this case, we calculate. Any idea why we have to use strain gauges rather than calculate? What's the purpose? Why do we use strain gauge and not calculate for this case? Is it because Eugene is a nutcase? No. Because, for example, if all of a sudden you have an earthquake, you're going to measure how the earthquake affect your what? Stresses. Can you tell me how much forces are induced by the earthquake? So what can you do? Measure. For this case, the known loads are given. Given by who? Given by your customer. I'm going to load my structure in this manner. Tell me what are my stresses. At the end of the day, you still have to adjust them or use small circle to determine those values. Okay. So the end product, okay, the end product, okay, before we do our end product, so the first thing you look at a question like this, you are going to construct your transformation. So number one, okay, number one we're going to do is to construct the transformation. Sometimes the transformation is given, sometimes it's not. For this case, it is what? It is given. Okay. So this is the cross-sectional view.